everyone. Today's lesson is a review of trigonometry for Chapter 8. So let's get started with our review. So to start with, there's a few things that you should know. Here's a list of most of them. We need to know geometric means and similar right triangles. You need to know special right triangles. Those are your 30, 60, 90s, 45, 45, 90s. A couple of proofs. I like this proof of the Pythagorean Theorem. You need to know the means. Of course, right triangles. That's the center of everything. You need to know applications of triangles. You need to know trig equations. You need to know inverse equations, which are arc sine, arc cosine, arc tangent. Remember, those are finding the angles. Some little mnemonics for remembering sine, cosine, and tangent. Remember to find the missing angle or the missing side for ratios. Pythagorean theorem, its converse. You need to know obtuse, acute, and right triangles. Oh, don't forget your triplets. And that's just a few of the things that we're going to cover. So let's start with the first problem, and that is to find the missing side length. Remember to use just exact values. So for this, we're going to find x. We don't know what that is. And so I'm just going to use the Pythagorean theorem, which is x squared plus 2 root 5 quantity squared is equal to 6 squared. I would advise you to, I'm going to move this over. I would advise you to be careful with this, because a lot of students look at this 2 root 5. You have to square that, the whole term, the entire quantity. And so be careful. And then another thing that I know that some students may forget is that this is a side squared plus side squared. Just because it's x doesn't mean that it's the one thing that you're solving. You're solving for it, but it doesn't go on the end. Okay, so this is going to be x squared plus, and I'm just going to write this out, 2 root 5 times 2 root 5 is equal to 36. So we have x squared plus, and then this problem we have 2 times 2, which is 4. Your numbers get multiplied with numbers. Roots get multiplied by roots. So root 5 times root 5 is root 25, which is 5. So we have 4 times 5. And that equals 36. So we have x squared plus 20 is equal to 36. X squared, subtract 20 from both sides, I get 16. So x is equal to the square root of 16, which is equal to 4. And so 4 is my answer. Okay? Next problem. Number 2 says solve for x, y, and z. So we have a lot to do here. To find x, we're just going to go basis to height as height is to base. So that one, 7 is to x as x is to 2. Base is to height, height is to base. And so now we have x squared is equal to 7 times 2, which is 14. So x equals the square root of 14, and you can't reduce that. So that's it. At this point, because I know the Pythagorean theorem, I could find y and z. That's up to you. If you want to use like hypotenuse, leg, etc., you can do that as well. I'm just going to use Pythagorean theorem for this. And so we're going to say to find the right-hand side, I'll just go over here. We're going to go the square root of 14, quantity squared, plus 2 squared equals z squared. So z is my hypotenuse. That's by itself. So we have 14 plus 4 is equal to z squared. So we have z squared is equal, I'll lift that up so you can see it. Z squared is equal to 14 plus 4, which is 18. So z is equal to the square root of 18. And we're going to reduce that. Z is going to equal the square root of 9 times the square root of 2, which is 3 root 2. So z is 3 root 2. For this problem on the left, we have a squared plus b squared. So we're going to go the square root of 14, quantity squared, plus 7 squared equals y squared. So we have 14 plus 49 is equal to y squared. So we have y equal, and we're going to square root this, whatever that is. Let's see, what's 49 plus 14? So that's 3, 4, 5, 63. And then I'm going to split that up into root 9 times root 7, and that equals y. So y equals 3 root 7. So that's y. So far we found x, y, and z. For this problem right here, we have, let's see, we know that these sides are the same. Now, you know you can use Pythagorean Theorem for this, right? You completely can do that. I mean, you also know the shortcut because it is a 45-45 right triangle. Remember that for this you have, for this value you have x, x, x root 2. It fits a 45, 45, 90. These are congruent. And you have a little formula. So going backwards, you take 12, right? And then the rule is to divide by 2, multiply by root 2. I get 6 root 2. So this value would be 6 root 2. This would be 6 root 2. Okay, so those are the missing legs. Now, I do want to remind you, though, that this is a fail-safe in that for the 45, 45, 90s, I mean, a couple of things you can do is you know that these are, even though you don't know the sides, right, you can do this. You can say, well, that's x squared, because I didn't know what that was, plus x squared is equal to 12 squared. You can totally do that. That's fine. You're going to get 2x squared equals 144. X squared equals, what's that, 72. You're then going to square root both sides. You're going to get x equals, I'm going to use 36 times 2. And so root 36 is 6 root 2. So I'm going to get the same answer for the length of my sides, but it's just another way of doing that. And I think the last way I could have done this would have been, if I know this is x, and this is x, and this is x root 2, I could have set this equal to x root 2. And in doing that, I would divide by root 2. So x equals 12 divided by root 2. And then, of course, I would multiply by root 2 over root 2, right, to get rid of the denominator. And I'd have 12 root 2 over 2. And that's what I got here. Do you see that? That's how you do that. And then you end up getting 6 root 2. So you have a lot of options for that problem, and, figure out how you like to do that. That's your choice. This one right here, I need to solve for the missing side lengths. So let's move this over here. And so let's see here. Well, I'm just going to call this A, B, C, just so I have some sort of reference of my angle. Or not. I mean, it's not necessary. Let's just not do it then. Okay, so in order to find the other lengths, I'm just going to call this x, this y. How about that? And in order to find x, let's just find x first. Put yourself at the corner. I'm going to put myself at, there's my hair. I'm going to put myself at 79 degrees. So in doing that, I am not trying to find the hypotenuse yet. I'm trying to find x. So I know that this is opposite to where I'm at, and I know this is adjacent. Okay, so you'd have to ask yourself, what uses opposite and adjacent? Okay, that's what I'm looking for. And remember your SOHCAHTOA, and that says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And keep in mind, if I'm not finding the hypotenuse, or I don't need to know that right yet, then I'm not using anything with the hypotenuse. So I'm not going to use sine or cosine. So I'm going to use, for this part of the problem, tangent. So I'm going to say, remember, tangent of the angle always comes after the word. Tangent of the angle is equal to opposite over adjacent. So that's going to be 18 over x. I'm going to cross multiply, okay? And when I do that, and I do need a calculator for this problem, so I'm going to cross multiply, and I'm going to get x times tangent of 79 degrees is equal to 18. And then I'm going to go x is equal to 18 divided by whatever tangent of 79 degrees is, okay? So I'm going to get my calculator out, and I'm going to figure this out with my calculator. You do need to make sure you're in degrees, okay? So I actually need to check and see if I'm in degrees. And in checking, going to my settings, my calculator, I see I'm in degrees. All right, so that's going to work for me. All right, so now I'm going to go to the calculator section. I'm going to go 18 divided by parenthesis, and I'm going to figure out what tangent of 79 degrees is. And I get 3.4988. So for this x, this is approximately, and it's approximately because I rounded this. Okay, your calculator is going to round that too. So we end up getting 3.4988. So I'm going to go with 3.5. And this does tell me to round to the nearest tenth, so we're good with that. So x is about 3.5. Now, I'm going to ask myself a little question here because this is 3.5, okay? And this is a lot smaller than 18, but I do want to stress that if you were to think of what this angle is here, and remember, the smallest side is opposite the smallest angle. And so therefore, this angle right here, 79, 89, that's 11, right? This does make sense for being the smallest side. 3.5 does make sense to be across from the 11 degrees, okay? Now, to find y, I do have a choice. I can use Pythagorean Theorem, 3.5 squared plus 18 squared equals a y squared. Totally fine. Or I can use sine or cosine, depending on where I'm at. I can use my 11 degrees, and I could say, I can say cosine of 11 degrees is equal to the adjacent side, which is 18 over the hypotenuse, in which case I'm going to cross multiply, and I'm going to get y times cosine of 11 degrees is equal to 18. Y is equal to 18 divided by cosine of 11 degrees. So I'm going to go 18 divided by parenthesis, and I need to put in cosine of 11 degrees. So cosine of 11 degrees, and that equals 18.3. So this is, so this is approximately 18.3. And so this is a side, this is my y, equal to about 18.3, okay? All right, cool. The diagonals of a rhombus are 6 and 12. So you know about a rhombus. Rhombus has 4 congruent sides. Rhombus has superpowers with diagonals because the diagonals form right angles here, okay? So we have 4 congruent sides, check. Diagonals are bisected, diagonals are perpendicular. So it told me that my diagonals are 6 and 12. So that means that this value right here is going to be 3 and 3, and that'll be 6 and 6. So for me to find the perimeter, that's just the sum of all the sides. I see I have a right triangle here. So all I have to do is to find one side length, and that's multiply that by 4. So I'm just going to use simply the Pythagorean theorem. 3 squared plus 6 squared is equal to x squared. So we have 9 plus 36 is equal to x squared. So x equals square root of 36 plus 9, which is 45. That's going to reduce into the square root of 9 times the square root of 5, and the square root of 9 is 3. So I have 3 root 5. So x, so one side of my rhombus is 3 root 5. So I'm going to take 3 root 5, and I'm going to multiply that by 4. Okay, so now I have 12 root 5. And please be careful, and that's my perimeter. Okay, please be careful that you don't multiply 4 times 5 because numbers get multiplied with numbers. Roots get multiplied by roots. I could completely multiply root 5 by another root, but since I'm just finding the perimeter, I'm adding. So it's as if I'm doing this. 3 root 5 plus 3 root 5 plus 3 root 5 plus 3 root 5. Okay, so that's 3, 6, 9, 10, 11, 12. 12 root 5. So same kind of thing. This one right here says that in San Francisco, California is famous for their steep streets. And the steepness of the road is also expressed as a percent grade. Okay. Percent is rise over run, or excuse me, percent is 1 over 100. 31.5% grade. That's really high. 31 and a half makes what? That's going to be 62 plus 1 is 63 over 2. So 63 over 2%. So that's going to be what? 63 over 200. This is my rise. This is my run. So my rise is here at 63 and my run is here at 200. And my job is to find that angle right there. So remember, when you're trying to find an angle, you have to use arcsine, arccosine, or arctangent. Okay. So what you do know is that you have the from here, put yourself here. Okay. There you are. There I am, whoever. Opposite, here's adjacent. You're not using the hypotenuse. You're not trying to find the hypotenuse. They're not trying to ask you how far you traveled. They're just saying opposite over adjacent, okay? So we're going to use tangent of theta is equal to 63 over 200. Now keep in mind, just like in inverse, this is an inverse, so we're going to move this tangent to the other side. Theta equals, this now becomes arctangent of 63 over 200, okay? And so I need to do that on my calculator, okay? So you should have your own calculator, or you should be using one in the classroom. So I'm going to go arctangent. So you're going to go trig function, find arctangent. Remember, make sure you're in degrees of 63 divided by 100, and we're going to approximate the answer 32.21 degrees. Ooh. So about 32.2 degrees. So that angle is 32 degrees. That's crazy. Anyway, that's how you do that. Now here's a different grade of road in Pacheco Pass. This is 6%. I feel like I did this one before. 6% is going to be 6 times 1 over 100. So that's 6 over 100. That's my rise over my run. Find the angle of elevation. Same thing, we just did this, okay? This is going to be opposite over adjacent, which is tangent. So we're going to say tangent of theta. Remember, theta always comes after the word. Tangent of theta equals opposite over adjacent. You can absolutely reduce this. There is no need to do that because your calculator is going to find that value for you. Theta equals arctangent, moving tangent to the other side, of 6 over 100. And so we're going to go arctangent of 6 divided by 100. And remember, on your calculator, if you're not using on these calculators, if you're not using a decimal point, you do need to approximate your answer. This angle of elevation is 3.4 degrees. So theta is approximately 3.4 degrees. And so this is this value right here, 3.4 degrees. And remember, I may ask you for the other angle too. And in order to get this angle, we just go 90 minus 3.4 degrees. Okay. Anyway, you know that. This one says, standing 30 feet from the Titan gym, you measure an angle of elevation, okay, of 38 degrees. So here we go. 38 degrees is my angle of elevation. Okay, that's the one that's looking up. If your eyes are 5 feet above ground, so basically you're looking like this. This is what they're saying. And this distance here that your eyes are is 5 feet. Okay, how tall is the gym? Well, the gym is this tall. Okay, and so therefore you need to get this value and then add, get that value and then add 5. Okay, so what we do need to know is a little bit of information that I didn't finish getting was that I'm standing 30 feet away from the Titan gym. So this distance from here to here being 30. Okay, so what I need to do is this is my hypotenuse. I'm not using my hypotenuse. I'm not trying to find my hypotenuse, by the way. This length here is what's called the line of sight. And I'm not trying to find that. They didn't ask me for the line of sight. They didn't ask me for the hypotenuse. I'm not using the hypotenuse. So that means that I'm just using tangent. So tangent of 38 degrees is equal to x over 30, opposite over adjacent. So we're going to go x is equal to, because I'm cross multiplying, 30 times tangent of 38 degrees. And so I need to figure that out first. So here we go. 30 times tangent. So I got to go to trig functions. Tangent of 38 degrees is equal to 23.4. So I get x is about, because I rounded this value, 0.4. So we're going to go 23.4. Okay, so that's this value right here. Now, remember what the question was. The question said, how high is the gym? Well, this right here is just based on your eyesight looking up, but you're up higher. So you are going to need to go 23.4 plus 5. Remember, line up your decimals. So we've got 482. So 28.4 feet up. All right, cool. Okay. Now, this right here is on a worksheet that you will be given. And so pull that out and let's go over some of these values here. So these are more review. Simplifying radicals and try to find a perfect root that will go into that. Root 28, that's just going to be root 4 times root 7. So that'll be 2 root 7. So that's my answer. This one will be 3 root 45, which is 3 root 9 times 5. 9 is 3, so that's 3 times root 5. Numbers get multiplied with numbers, so that answer is 9 root 5. You're not going to leave a root on the denominator, so you are going to multiply by whatever that root value is on the denominator. So we have 12 root 3 over root 3 times root 3, which is root 9, 3. Then 3 will cancel into the 12 4 times, and so we get 4 root 3. And so that's this value right here. For the next one, we're trying to find the geometric mean. Now remember, that came from this. Remember this triangle that we did before? And this is the three similar triangles. Base is to height, as height is to base. This mean, these two, okay? 4 and 10, so this is where this came from. All right, so you're just going to go, you don't necessarily have to draw the picture. I'm just telling you that that's there if you want it. So 4 is to x as x is to 10. We're going to cross multiply. X squared equals 4 times 10. 4 times 10. You can multiply that out. To me, it doesn't matter to multiply that out because I'm just going to reduce them. 4 times 10 is going to be 2 root 10. And that is equal to x, okay? This one, 9 is to x as x is to 16. I've got x squared equals 9 times 16. Square root both sides. We get x is equal to the square root of 9 times the square root of 16. So x is equal to 3 times 4. So x equals 12. And so had I multiplied these out here, right, that just tells me that this would have been right here, the square root of 144, which is 12, okay? For this one, now these are a series of problems you need to do each one individually. You're going to refer to the diagram. So the first problem says R is 3, so here's 3, this value. S is 6, find H. So again, base is to height, height is to base. So that's going to be, for number 6, we're going to go 3 is to h as h is to 6. h squared equals 3 times 6, which is 18. I'm going to square root both sides. H is equal to, that's going to be the square root of 9 times the square root of 2. So h equals 3 root 2. Okay. The next one is 7. And I'm going to erase this because each one of these is an individual problem, isolated from the independent of the other. So the next one says B is 6. So there's 6. C is 18. So that's the whole hypotenuse. Find R. So I want to find R. So this one I'm actually going to use hypotenuse leg. And so this one I'm going to use the small triangle. And this one I'm going to use the large triangle. So for this one, hypotenuse on this see the little triangle? Okay, hypotenuse, leg. So that's going to go 6 is to R as, now I'm going to do hypotenuse leg for the large triangle. So hypotenuse, right? Because that's opposite the right angle. So the hypotenuse is 18, leg, here it is, 6. And so we're going to go 18 times R equals 36. I'm going to divide by 18. R is equal to 2. Okay? And then the last one for number 8, again, I'm going to erase this because each one of these problems is independent of the other one. And we know that R is 3, so this is 3. C is 12. That's going to tell me that's 9. I need to find A. Now this is A. Now, okay, there are a couple ways to find A. One of the ways to find A is to do this and go 3 is to H as H is to 9. Find H. You have that. Now use Pythagorean Theorem. Okay. Another way to do that is hypotenuse leg equals hypotenuse leg. And so that's an option for you. I'm going to do this because that's 12. So I'm going to actually use hypotenuse leg just for fun. And I'm going to go the large triangle to the right small. Which side am I trying to find? A. To the right small. Okay, so hypotenuse leg. So large triangle. So hypotenuse is 12. So I'm going to go 12 is to leg A. As small triangle, here it is. Hypotenuse, I still don't know the hypotenuse, is to the leg. That's my leg. And so I'm going to go A squared is equal to 9 times 12. I'm going to go A is equal to the square root of 9 times 12. Square root of 9 is 3. 3 comes out. Square root of 12 is 4 times 3. 4 comes out. That's going to be 2. I still left with a 3 under my root. So little a is equal to 6 root 3. Okay? And, just for fun, because, what else do we have to do? I'm going to do what I was telling you before just to check. So we're going to go 3 is to H as H is to 9. So 3 is to H as H is to 9. I get H squared equals 3 times 9. H is equal to the square root of 27. Now for that problem, you guys, don't change it. That's square root of 27. I know I can reduce it, but don't, because you're going to just square that. Because that's to find A using the Pythagorean theorem. Okay, I'm going to go the square root of 27 squared plus 9 squared equals A squared. So that's 27 plus 81 equals A squared. 27 and 81 is going to be, 108 equals A squared. And I'm going to square root 108. So what is that? Let's see, 108. What goes into 108? I don't know, 4, 36 probably, since that's 6. But let's just start with breaking it down by 2. 2 times this 10 is going to be what? 54. 54 breaks down into 9 times 6. 6 breaks down into 2 times 3. So what I have is square root of 9, which is 3. That comes out. 2 times 2 is 4. Square root of 4 is 2. That comes out. And I'm left with this 3. So I have 6 root 3. 2 times 3 is 6 root 3. So I have that also. Just so you know, I had to do all of this work as opposed to this. Do you see that? If I just did hypotenuse leg, I would have had this a lot sooner than doing all of this extra work. Totally doable, just saying. It's a little bit more work. Okay, use a right triangle shown to find each value in simplest form. A is 4, B is 5. What's C? C is not 3. People see 3, 4, 5, see 4, 5, and they automatically think the other value is 3. Don't think that. Okay, this is number 9. This is my hypotenuse. So you got to go 4 squared plus 5 squared is equal to C squared. So you're going to go 16 plus 25 is equal to C squared. 16 plus 25, add those up, 2, 3 is 41, square root of 41, C equals the square root of 41. So this one is the square root of 41, okay? That's done. Now we got to find number 10, okay? 10, I'm going to erase this because this, again, is independent, okay? And for 10, we know A is 16, C is 20, and your job is to find B. So you're going to go 16 squared plus B squared equals 20 squared. So 16 times 16 is 256 plus B squared is equal to 400. B squared is equal to 400 minus 256. Subtract, and we're going to get 144. And square root of 144 is going to be 12. So B is equal to 12. Now, I'm not sure if you noticed this, but if I were to divide by 4 on both of these, this would have been 5, this would have been 4, and dividing by 4, this would have been 3. So 3 times 4 was 12. So I could have figured it out another way. I'm not sure if you noticed that. Okay, let's erase this again and do the last problem, which says A is the square root of 5 and B is 2 root 5, find C. So that's your C. Now, I love these kinds of problems because it does kind of test your knowledge as to roots. So let's do this. A squared plus B. Okay, so we're going to go the square root of 5, quantity squared, plus 2 root 5 quantity squared equals C squared. So we have 5 plus, now I'm going to do this one out, 2 root 5 times 2 root 5 equals C squared. And then 2 times 2 is 4. So that's 4 times root 5 times root 5, which is root 25, which is 5, plus 5 is equal to C squared. So this is 20 plus 5, 25. So this is 25 is equal to C squared. Square root both sides, C is equal to 5. So this value right here was 5. Whether the triangle with sides of the given length are acute, right, or obtuse, if you remember, if C squared equals A squared plus B squared, it's a right triangle. If C squared, C being the largest angle, okay, largest number, right? If, not angle, side. If C squared is greater than the sum of the other two, A squared plus B squared, it's going to be obtuse. But if C squared is less than A squared plus B squared, okay, if it's less than, then it's acute, all right? That's obtuse. Now, one other thing that you need to look out for, and that is it a triangle? Because remember, the sum of two sides of a triangle have to be greater than the third side, or you're going to get something like this where it just like doesn't connect. So just checking in the beginning, 3 plus 5 is 8. 8's greater than 6. 1 plus 2 is greater than, well, do we know that that's greater than 3? We'll have to check that out. What approximately is 5? The square root of 5. Let's think about that. Square root of 5 is in between, I would say, the square root of 4. Do you agree with that? And the square root of, that's 2 squared. And 3 squared is 9. So we know that that's in between there, right? So it's in between 2 and 3. well, it's close to 4. It's close to that. So I'd say like 2.1 or 2.2, right? So is 1 plus 2, which is 3, bigger than this? Yes. So therefore, that would probably work. And then lastly, 10 plus 10 is 20. This is bigger than that. Okay, so all of these are triangles. Now we just need to find something, whether or not they're right, obtuse, or acute. So what we're going to do is we're going to say, well, where's my biggest side? 6. Where's my biggest side? This is 2.2, so it's got to be this. Biggest side is here. Okay, so we're going to go 6 squared. Is that greater than, less than, or equal to 3 squared plus 5 squared? And so that actually is what? 36 greater than, equal, or less than 9 plus 25. 9 plus 25 is 34, which means this is bigger. So this value, this one, is obtuse. Okay? Now this one, we're going to go, what is that? Root 5 squared is what to 1 squared plus 2 squared? Square root of 5 squared is 5. And 1 squared is 1. 2 squared is 4. 4 plus 1 is 5. Oh, they're equal. So this one here is right. Okay? All right. And then this one, we're going to take the biggest side. So 14 squared is what to 10 squared plus 10 squared? So that's 196 is what to 100 plus 100? That's 200. Oh, it's less than. So therefore, this is acute. Okay? Find y. Oh, well, this is a 30, 60, 90 right triangle. So remember 30, 60, 90 right triangles? Where we have opposite the 30 is A, opposite the 90 is 2A, and opposite 60 is A root 3. So opposite the 30 is A, opposite the 90 is 2A. Well, so that means A is what, 20? So across from the 30 is 20. And then across from the 60 is A root 3. So that's going to be 20 root 3. For this one right here, it's a 45, 45, 90. And then again, a 45, 45, 90. See, 45, 45, 90. We said x, x, x root 2. So if this is 10, then that's 10, 10, 10 root 2. Now for this one, let me move this up a little bit. Let's do this. And there we go. Okay, separate those a little bit. So our job is to find x. And what we know, okay, is that this is a 30, 60, 90. And let's see, across from the 90 is equal to 2a. So that means a, so I'm going to divide. So if 6 root 3 is equal to 2a, and I divide both sides by 2, remember numbers cancel with numbers. So 2 goes into 6, 3. So a is 3 root 3. So that's across from my 30, 3 root 3. So then across from the 60 is a root 3. That goes here. Well, if a is 3 root 3, then what I'm going to write is 3 root 3. That's my a, and then root 3. So what that becomes is 3 times the 1. So we have 3 root 9. Well, what's the square root of 9? That's 3. So we have 3 times 3, which is 9. So this value right there is 9. Now this one right here, to me, let's see what this looks like. Okay, find x. All right, so that's right here. Well, that's opposite the 60 because that's a 30, 60, 90. This is a 45, 45, 90. So this goes x, x, x root 2. This one is nice. There's my x. 3, 3, 3 root 2. Across from the 30 is my a. Across from my 90 is 2a, so that's 6. Across from my 60 is a root 3, so that's just 3 root 3. So the diagonals of a rhombus have lengths 4 and 12, okay? Remember our favorite thing in the world, rhombuses, okay? And so our rhombus, I'm going to draw my rhombus with superhero powers diagonals. And the lengths are 4, so 2 and 2. That's 6 and 6 for 12. And again, I'm just trying to find the length of a side. So we're just going to go 2 squared plus 6 squared is equal to my hypotenuse squared. So 4 plus 36, which is 40, is equal to x squared. I'm going to square root both sides. I'm going to get x equals the square root of 40, which breaks down into 4 times 10, which is 2 root 10. I do want to remind you that one of my sides is 2 root 10, but you better be careful right here, okay? While the square root of 4 times the square root of 36 is 2 times 6, okay? The square root of 4 plus the square root of 36 does not equal the square root of 40. You need to be very careful. Do not square root these, even though this is equal to x squared. Do not square root those. You have to add those first and get the square root of 40. You have to add these first before you square root. Find the sum, then square root. Okay, be very, very careful. All right. The next one says the vertex of an isosceles triangle. So, yep, you do need to know what a vertex is. So isosceles means these two sides are congruent. The base length is 18 right there. The length, find the length of the altitude. Well, I need this value right here. And it just told me that the vertex of an isosceles triangle is blank. Well, I don't know. I think I'm missing some information. Let's just say the vertex of the altitude, I don't know, let's just say it's 20, let's say that's 40 degrees. So let's say that's 20. I love this idea. Okay, so let's just say that's 20. It's not on your paper, it's something else, and I don't know what it is right offhand. So we're just going to call it 20. That makes that 9, and your job is to find the length of this altitude. Well, you will need your calculator for this, okay? So for this problem, to find the length of the altitude, which is the height, and all I did was I took this right triangle here and I redrew it. To find the altitude, I'm not using the hypotenuse, so that means I'm not using sine or cosine. So I'm going to say tangent of 20 degrees is equal to opposite over adjacent. So 9 over x. And so what I'm going to do with that is I'm going to cross multiply, and I'm going to say x times tangent of 20 is equal to 9. So x is equal to 9 divided by tangent of 20 degrees. Okay, whoops. And then I got to use my calculator. So I'm going to say 9 divided by, parenthesis, tangent of 20 degrees, okay, is equal to 24.7. So this value, so x is approximately 24.7. Now, I just want you to keep in mind, I don't have this number here, so I don't know what they're asking, so I just made up this number right here for 20. Whatever it is, you can figure that out. In questions 21 to 24, refer to the diagram at right. So this looks like a 5, 12, 13 triangle, okay, doesn't it? Okay, so there's 12, 13, so that's a 5, 12, 13. So find sine of r. I think the biggest thing for this is what they're trying to do is they're trying to tell you, put yourself in different parts of the triangle. So when it says r here, this is the angle, you're here. So sine is opposite over hypotenuse, so this would be 5 over 13. Cosine of r would be adjacent over hypotenuse, so that would be adjacent 12 over 13. Now, to find the other side, so now yours says t. So this is still 5, but now I'm here. So sine, again, is opposite over hypotenuse. So that's 12 over 13. And tangent is opposite over adjacent. So that's going to be 12 over 5. Again, I just want to stress, this is an improper fraction. Leave it alone. That's your answer. Do not change that into a mixed fraction. Okay? Okay. And well, I know I wasn't going to say anything, but I do want you to just kind of keep in mind, see these two. Cosine of r is the same as sine of t. When you get to algebra 2, trig advanced, we call those cofunctions. Okay? All right. So these problems here, write the letter of the equation that could be used to solve for x. So right off the bat, for me, I'm just going to say opposite over hypotenuse. So I'm going to say sine of 50 is equal to x over 75. Now, I notice that none of my answers are there. I don't see this, but that's what I would do right at the beginning. Now I'm going to look at this and say, well, I guess I could, if that's 50, I know that's 40. So let me try 40. Let me try from 40 because this wasn't one of the answers. This is a way to do it, but it's not one of my solutions. So now I'm going to try it a different way. Now I've got to put myself at 40, not 50. So that being the case, this is now adjacent. So that means I'm going to use cosine. So cosine of 40 degrees equals adjacent over hypotenuse. Now, is that there? Cosine of 40 equals x over 75. There it is. So just be very careful. Those values aren't always going to be there. Okay, so the next one, what do I need to find? X. So I'm going to start with 51 again. To find x, I can do, let's see, I can do tangent of 51, which is opposite over adjacent. Let's see. Tangent of 51 degrees is equal to 14 over x. Well, that's not one of my options. So that means I'm not going to use tangent of 51. But I could use possibly tangent of 39. Let's see if I put myself at this end. Okay, if I put myself at this end and I would go tangent of 39 is opposite x over adjacent, so that's x over 14. Oh, there it is. Okay, so you can try different ones. Just keep in mind, I want to show you something here. Why wouldn't cosine of 51 work? So I just want you to look at this one right here. If you put yourself at 51 degrees, cosine of 51 is going to equal x over my hypotenuse. So that, see that 14? That should be 18. That's why that one doesn't work. And the last one is saying this value here. So x equals, we don't know. So one of my choices at x is going to be tangent. So I could say tangent of x is equal to opposite over adjacent, or I could say sine of x is equal to opposite over hypotenuse, 80 over 100. I could say cosine of x is equal to adjacent over hypotenuse. So look at all the different ways I could do this, okay? And in this problem, right here, oops, let me erase this. Hold on a second. I want to do that last one again because I know you can't see it down there in the corner. Cosine, and that's the one I wanted to use. Cosine of x is equal to adjacent over hypotenuse. So 60 over 100. So remember how to find this. This looks like it's this one right here. 60 over, oh, that's not it. Hold on. Okay, that's just a little small for me. I'm going to go back and come back. Okay. Tangent of x, so what are my options? Is equal to 80 over 60? No. Sine of x is 80 over 100. There was my answer right there. Okay. All right. Now, I just want to remind you of something. Like, let's say this was my answer here, cosine of x, and that was one of the ones they chose. To find the angle, remember, cosine has to go to the other side. That's going to become arc cosine of 60 over 100. Okay, and then whatever that equals is your angle. And this is the last problem. The angle of depression from the top of the tower is 23. I want to stress again that your angle of depression is always based on a horizontal. It's going to be this value here. That value, that being said, remember how these lines are parallel? Parallel lines have alternate interior angles congruent. That's now 23 degrees. And we're looking at, let me use a different color. We're looking at this right triangle right here, okay? And they want to know the distance from A, well, they said the distance from A to B is 80. What's the height? So we're trying to find this height. So we're going to use opposite over adjacent. So I'm going to use tangent of 23 is equal to x over 80, opposite over adjacent. Solving that, I'm going to get x equals 80 times tangent of 23. So x is equal to, I'm going to use my calculator. I'm going to go 80 times tangent of 23 degrees. And I get 33.95, so almost 34 degrees. So this is about, so this is approximately, not degrees, 34, am I in feet? Meters, 34 meters, okay? So this length is equal to about 34 meters. I know that's not one of my answers because I went through and worked out the problem. The answer would be C. I'm just showing you that, how to finish the problem and work it out. Okay. I think that's it. So, hey, good luck, and please email me if you have any questions, and thanks for watching. All right, bye.